This is a video lecture on electronic circuits. The objective of this course is to understand electronic circuit theories and to develop problem-solving skills through the application of principles and techniques to various electronic circuit problems. These are the contents of this course. This is the flow of this video lecture. First, you will listen to the lecture on principles, laws, and theorems together with experiments and exercises. You can pause the video and follow the instructions, and learn how to solve problems. Then you will have a few homework assignments. Now let's start Lesson 1, Diodes. Section 1.1, Ideal Diode. This is the symbol of diode. It has two terminals labeled as cathode and anode. The directions of the terminal voltage Vd and the current Id are defined as in this figure. If Vd is positive, then the diode is said to be forward biased. And the positive current is called forward current. If Vd is negative, then the diode is said to be reverse biased. And the small negative current is referred to as reverse current. The ideal diode has this characteristic. If it is forward biased, then Vd equals 0. If it is reverse biased, then Id equals 0. In other words, the impedance is 0 when forward biased, and infinite when reverse biased. Assume that an ideal diode D and a resistor R are connected in series, and a voltage source with a voltage V is connected to this DR circuit. Assume also that V is sinusoidal. When V is equal to or larger than 0, then the diode is forward biased. The diode can be represented by a switch, and it is turned on. And Vd equals 0, and Vr equals V. When V is negative, then the diode is reverse biased, and the switch is turned off. And the current Id equals 0, and Vr becomes 0. Thus, in this case, Vd equals V. Section 1.2, Real Diode. This photo shows a 1N40-148 diode. This type of diode is a silicon diode. Its dimensions are 3.2 mm in length and 0.5 mm in diameter. This is the symbol of diode. The direction of the diode in the photo is the same as that of the symbol. A cathode of real diode is marked with a color line. The cathode in this photo has a black line. Experiment 1.2. Pause the video, and follow the instructions. This is to obtain ID versus Vd characteristic. This is the answer to experiment 1.2. This is a snapshot of the oscilloscope display. This is the measured waveform of the source voltage V. The horizontal axis is time, and 10 milliseconds per division. The vertical axis is 1 volt per division. 0 volt level is indicated by an arrow. These are the measured waveforms of the diode voltage Vd and the resistor voltage Vr. The orange line is Vd and the purple line is Vr. The distinct difference from the waveforms of the ideal diode was that Vd is higher than 0, when the real diode was forward biased. From the waveforms of Vd and Vr, this characteristic of real diode was drawn. The horizontal axis is Vd, and the vertical axis is the diode current Id. Id was calculated using Ohm's law, that is Vr over R. This shows the wiring between the input-output pins of the ADALM2000 and the DR circuit. This is the experimental circuit. The USB instrument outputs the sinusoidal voltage from the W1 pin and the G pin, which can be the source voltage V. The diode voltage VD is input to the USB instrument through the 1 plus and 1 minus pins, which serve as the inputs to the oscilloscope. The resistor voltage VR is input to the oscilloscope through pins 2 plus and 2 minus. The details of the ADALM2000 are available at this URL. For PC software installation, visit this URL for this USB instrument quick start. This shows details of the wiring. Pause the video, and check the wiring. This is a photo for the wiring. The diode D and the resistor R are inserted into the breadboard. This is a photo for the wirings between the ADALM2000 and the experimental circuit. Pause the video, and check the wiring. Exercise 1.2. This is your homework. Pause the video, and draw the answer. The author of this material is Takeshi Furuhashi, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.